And we are live. So, welcome everyone to Climate Chat. I'm your host, Dan Miller. And today we have an open discussion rather than an interview show, which people, if they recall from the early Clubhouse days, that's normally what we did. We had an interview once in a while. Now on YouTube, we typically have interviews about 80% of the time. I'm about to tell you some exciting interviews coming up in just a moment. But I do want to remind everyone to subscribe to the channel and to like the channel because as we talk about often, it's really important that everyone talk about climate change. And this is a place we're talking pretty seriously about climate change. And so the more we can spread this out, the more engagement we have and more people are aware of what's happening. So it's a little thing, but an important thing to do to help move climate discussion forward. So like, subscribe, and follow on Twitter and especially on Bluesky. I'm moving up on Bluesky. I have about 1/10 the followers on Bluesky that I do on Twitter, but I'd like that to change. So please check out Bluesky. It's also at Dan Miller 999, and then it's dot Bluesky, whatever, social. Hold on one second as I take care of Eli, our co-host here. Okay. So
Hi, Dan.
today we're going to talk about 2024, a year in review. And just before we go there, let me tell you about some exciting upcoming guests in the early part of the year. One will be James Hansen returning, one of our obviously most popular guests and one of the most important climate scientists in the world. He tells it like he sees it, and he usually has a better perspective on things because he looks at climate as a system, a total system with everything interacting and what are the different parts, where very often a climate scientist might focus on Arctic sea ice or on AMOC or on whatever. And Jim looks at the whole picture and therefore gets insights that others seem to miss. But so that'll be super exciting. And it will be even more exciting because what we'll be doing is covering Jim's new research that isn't published yet. So that's going to be really exciting. Another really exciting guest, Bill McKibben. Bill McKibben, for those of you who don't know, is probably the longest serving climate journalist. He wrote a book, The End of Nature, I think it was the 80s. And he got me started in climate because I read an article he wrote about Svante Arrhenius, this Swedish Nobel Prize winning scientist who calculated how much the world would warm for a doubling of CO2, and he did it in 1896. And then he talked about how much CO2 we're putting in the atmosphere and how climate change is going to be a big thing. This was in the early 90s that I read this. And I just remember having this feeling that, wow, I can imagine this being real because it wasn't a real thing back then to most people. And then I started learning more, speaking with climate scientists and getting engaged more and more. And so I've been at it for a long time, and I have Bill McKibben to thank for that. We'll also be having David Keith as a returning guest. David is probably the best known person in the solar geoengineering field. More than that, but solar geoengineering certainly something that he's been writing about for a long, long time. We had him on already, and we covered so many subjects that we didn't have a time to really focus on solar radiation management or solar geoengineering. So he's agreed to come back so we can focus on that subject in particular, and that's a very important subject. So those are just three guys. There's a bunch of others lined up, some you haven't heard of, but they have done really interesting research and covering different issues like migration. And anyway, it's really an interesting group of people coming up in the early part of the year. Okay, so with that, I want to move on to the main subjects today, which are a review of what are the most important issues, research findings, and events in 2024 regarding climate change. And this is an open discussion, so you are welcome to comment, give your own thoughts on what's important, ask a question about some of the things I'm talking about. If you're on Clubhouse, you can, first of all, you can join the Zoom, or you can put comments in the chat there. If you're on Zoom, you can put them in the chat or raise your hand for ask a live question. And if you're on YouTube, in the comments, please preface whatever you say with the word question or comment, colon, so that it's easier to spot from just the regular chatting that's going on over there. So let's get right into it. And I have, this is not in a particular order, but at the top of my list, I have the accelerated warming that we experienced both in 2023 and 2024. In 2023, it was thought, well, this is all part of the El Nino, so it's not that unusual. Yeah, it's a little bit more, but whatever. But in 2024, when the El Nino went away, it was still there and it was just as strong as before. And as we had lots and lots of discussion on this over the year, including with Leon Simons, who is a co-author with James Hansen on the Global Warming in the Pipeline paper, which came out in November of the previous year. He's the one who studies the fact that ships have been emitting less sulfur into the atmosphere because of International Maritime Organization rules that came into effect in 2020 that ships had to have 80% less sulfur in their fuel than previously that they had before the rules started to go into effect, I think, in 2015. And this sulfur itself emitted from the ships reflects sunlight, so that would provide some cooling. But more importantly, the particles, the sulfur particles, act as nuclei for water droplets to form clouds. So the ships, as you could see from satellite photos, have long clouds, long thin clouds trailing behind them. And clouds are white and reflect a lot of sunlight. The ocean without a cloud is dark and absorbs a lot of sunlight. So there's a huge difference in what's called the albedo of that area where the ships are. And when they cut back on the sulfur, they obviously had less reflecting sulfur, but also more importantly, less reflecting clouds. And this ended up being a big thing. Now, this is not settled science. This is not all scientists agree. There's two camps. There's those who believe with Jim Hansen and Leon Simons that these rule changes made a huge difference, and those who say we don't know. In other words, they don't have an answer. They don't have an alternate theory. They just say we don't know what it is. In fact, and some of them say the ships can't cool the Earth that much. But Jim and Leon and others have made, I think, a good case for why they can. Again, it's the cloud issue. It's not the particles themselves reflecting the sun, but it's the clouds they form. And that could make a big difference, again, over pristine ocean versus the land. Like in China, they've been cutting back on sulfur emissions from their coal plants. So why doesn't that have as a big effect? Well, there's lots of other forms of pollution. And once you clear the pollution, it's not dark water underneath. There's still land that reflects the sun. So the impact is not quite as much. And when you take a look at the North Pacific and the North Atlantic, where most of the shipping is, those are the areas that have heated up tremendously. The oceans there have heated up tremendously to the point where they've essentially formed a permanent El Nino. Now, the El Nino officially is in the Central Pacific, and that's a hot spot that comes and goes. Sometimes it's a cooling spot, sometimes it's a heating spot. When it's a La Nina, it's cooling. When it's an El Nino, it's warming. But in the North Atlantic and North Pacific, when you look at the temperature signature, you see it looks kind of like an El Nino but in a higher latitude than what the regular El Nino goes. And that is causing the world to warm a lot, on the order of 0.2, 0.3 degrees, on top of the plus and minus you get from El Nino and La Nina, and a little bit from the sun in its 11-year cycle, and other natural variations. So a lot of climate scientists are scratching their head. How can it, be so warm? What's going on? What's going on? And of course, Hansen and Simons and everyone have been saying what's going on for a long time. Well, not a long time, but for a couple of years. And I'm not exactly sure why they're not being believed. But on this program, you can see We've had discussions with a bunch of people that don't, they wouldn't say they don't believe it. They just would say, oh, not sure yet. Yeah, Stacy, hi.
Hi. It's the same as everyone else. They're just falling into that trap of it's inconvenient. It doesn't match with what they've been saying and it doesn't match with the hey, we can do it. We can get ourselves out of this that people have been saying. And I want to believe that. I I do. I do. I do. I do. But yeah, we're
Well,
not
actually,
doing
you're
the
bringing
things.
up something that I have a little bit later on, but I'll bring it up now. And I think it's a little bit different than what you're saying because I'm talking now about climate scientists versus sort of like politicians and business leaders. And when
Oh,
it comes
I
to,
am too, Dan.
I know you are, but I think it's a slightly different thing. And this is something that Jim Hansen wrote a paper about. I think it was 2006 or maybe 2008, so a long time ago, and he called it scientific reticence. So you can look this up, James Hansen, reticence. There's updated versions too, by the way, but the original one. And so here you're a professor and you're a researcher in climate, and you have this data, let's say on sea level rise, and you've done your research, and you think there's a 50% chance that that the sea level is going to rise 10 feet in 2100. Okay, that's mind-boggling, right? That would be crazy. But you're 95% sure that it will be at least 3 feet. Okay, because
Mhm.
there's a lot of things, a lot of variables, and you can't be sure. So you're 95% sure that it's going to be 3 feet. 50% sure it's going to be 10 feet, and maybe 5% sure that it's going to be like 15 feet or something crazy like that. If you're going to write a paper, you're going to write a paper about the 3 feet. Now, why are you going to do that? You're going to do that because to publish a scientific paper, you have to be correct. You have to be confident within two sigma, it's called, two standard deviations. That's 95%, surety. So, and if you publish that, it's much more important when you publish a paper that you're right than you get really hurt if you're wrong. But if you don't publish something that would have been right, but you don't publish it, you're not hurt at all. But if you do publish and you're wrong, then your reputation is ruined, right? So we
And they'll
have a
never listen
system
to you
that is
again.
set up
Yeah.
to encourage people to be conservative, and that's normally okay when you're talking about black holes or you're talking about, atomic physics or something like that. And you might
Or
want to wait a little while until, the new research kind of proves it out and gets you into that 95% number. But when you're talking about an existential threat to humanity, it's a terrible thing to do. And the military would never do this, right? Let's just say there's a 50% chance that China's going to invade Oregon tomorrow. You know, you know, well, the military doesn't go, well, it's only 50%. I mean, let's wait till we get more data and until we no,
Biden would have,
if it was a
or
1% chance, they would go
Biden or
crazy.
Harris, one of them would have the football right now, if that were the case.
Yeah, so no, but even a tiny percent in that. So climate science, which is following the rules of science, right, is set up. It's built in. The incentive system is built in to underplay the effects that you would normally be very aware of in like a military situation.
Hmm.
And and that is, we're seeing that over and over again. And that's why you keep hearing the phrase, it's worse than client scientists thought, right? It's a very common phrase
So,
in like news articles about whatever latest disaster is, right? And they get, well, it's warming faster than scientists thought. It's doing, seas are rising faster than scientists thought. Methane is going, it's not that scientists are stupid. It's that the actual system they operate in, their reward system, is set up to be conservative. And as other people have said, and I like this quote, is that climate scientists are conservative in the opposite way that a risk manager, for example, from an insurance company, is conservative. So the risk
A couple
managers have,
of a few comments on this.
yeah.
So
Welcome, Eli.
what he's saying is definitely true of climate science. My background is biology, and it's a bit different because like climate, biology is inherently complex, and there's just no way of pretending that it isn't. And the roots of climate science, by contrast, are more in physics and some chemistry, right? And in physics, they really do want to, nail down the second sigma, the third sigma, the fourth sigma, really tight confidence intervals progressively. And also, modeling has been much more important, over the course of the development of the field. In biology, you do your experiments, you do the best you can with them, you report the results provided they're reproducible, right? And people do get it wrong, and it's okay. And occasionally, there are some people who like get a reputation not to trust them so much, etc. But they're everybody in the field understands just how complicated things are. Now, biology has been politicized in various ways, going back, centuries actually. Climate science is very politically controversial, and there has been a lot of blowback, and that, I think, makes people even more cautious because they don't want to be called in front of Congress and ripped to shreds, the way various people have been. The real way of doing this for any science would be, look, here are my methods, here's the data I used, here's the expected distribution, right? The 3 feet of sea level rise, there is at least a 90% chance of that. But there's also this other, 5% chance of 6 feet, for example. And that's totally honest, and that can be totally supported. But I think the thing is that they also understand that 1% is going to be, or that 5% is going to be politicized, and people are going to try to roast them for it.
Well, they see that I guess in the IPCC reports where they do present this data, and they give these high confidence kind of things, low confidence, and people misunderstand those words, the context that those words are used. But and then they write a summary for policymakers, which is a very political document that Saudi Arabia edits and censors and things like that. So there's a lot of issues. Well, as a whole, we'll talk a little bit about COP later, but there's a lot of issues there. The bottom line is that this is an existential threat. That means it's a threat to civilization. It's a threat to your families, and not really long time frames, in decades, not centuries. And we should be taking serious action to fight it, and we can. As I always say, I'm quite optimistic about what we could do. I'm not necessarily optimistic about what we will do, and I'm certainly not optimistic at all about what we're doing right now. So we're really not taking it seriously. Part of it, I think, is the fact that scientists are conservative in the wrong way for a subject like this. And so
I
it
think
is,
that we need,
that's,
I think that we need something like, because I'm thinking, well, who gets to say things, they don't come true, and they live on to fight another day? And that's like political pundits. It's almost like we need climate pundits, that people would actually listen to, that it can be the buffer between the scientists and the public, that can spin it or whatever. I guess it just has
welcome
to
to
have.
Climate Chat.
Yeah. So I guess that's us. Yeah. Yeah. So,
Yeah.
yeah,
Well,
here we
we
go.
listen to the scientists and we tell what they're saying, right? But we're also willing, in our case on Climate Chat, we're willing to kind of believe certain scientists like Jim Hansen more than others. His track record is really, really
Yeah.
good. And he looks at the big picture. That's something that, we've talked previously on Climate Chat about the need for systems thinking. And by the way, we'll be talking about various things today. You can look them all up on Climate Chat. Go to the list of recent streams and just go back a year and you'll find all of this stuff being discussed
I-
in much more detail than we're going to do today.
I still think it's astounding. I watched, and I know I've said this before. Right before we had Hansen, I watched this sort of, it was some anniversary of something. And so all the big climate scientists, and I think all but one of them we've had on our show, and they were lauding Jim, saying all these things, how outstanding he did, how he did it with such little technology at the time, was able to predict so closely, so clearly where we are, just giving him all the praise that he deserves. And then some of those turn around and say, but he's wrong now. Or I'm not sure.
Well, they won't say he's wrong. I think they wouldn't go quite that far. They'll say.
What do they say?
They say things like the data doesn't support what he's saying right now. That's what they're looking for. Again, they're looking for that 95%. And even Jim probably would say, well, I don't have 95%, but look at it. It's obvious what's happening. The data supports it. And he's willing to say, this is a really serious situation. We have to deal with it right now.
He'll go to Climate Casino and put all his chips down on it.
Perhaps. So by the way, so back to the fundamental thing, what's happened with this very rapid acceleration in warming, really mind-blowing in the last 2 years. And that is that we've hit 1.5 C of warming. And there's a lot of controversy about that. And I'll just sum it up. If you take a look at long-term trends, you take a look at a 30-year trend, obviously the past cooler weather is going to dominate that. And even if you weight it for the more recent numbers, you're going to end up with like 1.3 C or something. But if you look at the current warming, which is actually 1.6 right now, and you say, well, it's 1.6 because, well, there's not even an El Nino anymore, but you could argue those kind of things. It's going to cool off, which it probably will cool off when there's a La Nina, which might happen. There's some question about that. But if so, the La Nina will only bring it down to like 1.4. And when you're bouncing between 1.6 and 1.4, that means you are at 1.5 as the underlying base temperature. The base temperature, or the trend temperature, is the temperature which you go up from and down from based on natural variability like La Nina, El Nino, or the sun cycle, or these other things that might happen. So what's happened is we fundamentally changed the amount of cooling from sulfur on the planet. And remember, the warming we're at is equal to the amount of warming from greenhouse gases minus the cooling from aerosols or pollution. Aerosol is another word for pollution. And as we clean up the pollution, we're seeing more and more warming. Now, by the way, this is also a very important part. We've done whole programs on this, but Jim Hansen, and again, Leon Simons and others, their paper, Global Warming in the Pipeline, said that the warming from greenhouse gases, instead of being probably 3 degrees for a doubling of CO2, which is what the IPCC uses as its sort of mid value, they said it's probably 4.8 degrees, which means a lot more warming for a given amount of greenhouse gases. But they also said that the cooling from the aerosols is more than the IPCC assumes, which is why the current temperatures are about the same, right? Because the IPCC is this much warming from greenhouse gases, this much cooling from aerosols, so you're here. And Jim is saying, no, it's this much warming from greenhouse gases and this much cooling from the aerosols, so also still there. The problem is, as you clean up the aerosols, that means your temperature is going to go up faster than scientists thought. So that's a really big, important story for 2024 and 2023, that we did this huge step change in temperature because of this one rule change in the International Maritime Organization for good reasons, right? This pollution kills a lot of people. And although over the oceans, probably not that much, but when they come to port and things like that, that pollution harms people. And uh, and so by making that change for human health reasons, we've accelerated climate change tremendously. And so not only did the temperature go up, okay, yeah, we could measure that, but all of a sudden impacts have jumped, right? All of a sudden you're seeing cars floating down the center of streets every week,
Car soup.
several times a week sometimes. And it has a new word that's come out of it. It's called car soup, where you just see cars bobbing up and down, going down the street, the main street of a town. And that certainly has happened in the past, but not like every week, not 3 times a week as we're seeing it now. So the thing is, when the the averages go up a little in climate change in general, when it comes to temperature, when it comes to precipitation, and all of these, or rain intensity, when the average goes up a little bit, the extremes go up a lot. And I did
Dan,
like a whole paper,
something.
I did an article on this, but it's just without going into the details. And that's why when you jump 0.3, 0.4 degrees, which we did in a couple of years, all of a sudden you see much more devastating heat and drought, and you also see much more, and a warmer atmosphere holds more water. So you go up that much, you're holding significantly more water in the atmosphere. That all comes down as a thing. We had Daniel Swain on, and he talked about how you can think of the atmosphere like a sponge. As you get warmer, you have a bigger sponge, so it can do two things. It can suck up more moisture from the land and make it drier. And then also when you squeeze it, a lot more comes out and you have more torrential kind of rain. And so we're seeing that too. So
Dan,
so not only did the temperature jump, but the impacts jumped as well. Yeah.
the something you mentioned earlier, that differential, the that was about the aerosols, that the heating they're masking is higher than, and but the cooling that they provide is cooler than what IPC.
The impact of aerosols is more than assumed. Yeah.
Impact of aerosols. Okay. So that means that for the not that SRM, that it would take possibly less than what may have been calculated to have certain income impacts. The other thing that it presents is termination shock would be even more catastrophic if it were to be halted.
No, it's actually a little different for SRM, because let's be specific. SAI, stratospheric aerosol injection, is when you put sulfur particles in the stratosphere.
Yes.
We're currently putting
actually it's reflective particles, because there
reflective.
are other alternatives.
It doesn't have to be sulfur.
Probably much better alternatives like diamond is being investigated as one example.
Yeah. So but you can put reflective particles in the stratosphere.
Lucy.
But the thing is, we're currently doing this today on a massive scale at 20 times the level we need to do it in the stratosphere. We're putting sulfur particles in the troposphere, where we live and breathe. And there's a number of factors. But we're doing it by accident. That's the ships, that's the coal plants, that's the industry, that's the cars spewing stuff into the lower atmosphere. Contributes to the deaths of 8 million people a year. 1 out of 5 deaths on Earth caused by burning fossil fuels. So it's really bad for human health. But the other thing is those particles, which do contribute to clouds when done right, like the ships, but they fall out of the atmosphere in about a week. So they're very short-lived. But when you put sulfur particles in the stratosphere, here's the thing. They don't really contribute to the clouds, so they don't have this amplifying effect that Hansen and Simons are talking about up there, but they last for a year or more, maybe 18 months, maybe a couple of years. And therefore, you need far, far less of them to, so instead of 100 million tons like we're doing today, might be a little less than that now, 80, 100 million tons of sulfur spewed into the lower atmosphere where we're breathing it. you put 5 million tons up in the stratosphere. And again, you won't have the cloud effect, so you actually need a little more than you would have needed if it did have a cloud effect. But again, you need far, far less of it because it lasts so much longer there, cooling the Earth. And we know it will work because it happens a few times a century naturally when there's a very large volcano. The last one was Mount Pinatubo that cooled the Earth for a couple of years by about half a degree by spewing sulfur particles into the stratosphere. And we're still here, by the way, so we know it's not a catastrophic thing to do. In terms of termination shock, which for the audience might not know what that means, it means when you're artificially cooling the Earth by putting, let's say, sulfur in the atmosphere, and then all of a sudden you stop. Let's say there's a war or economic calamity or climate calamity that prevents you from continuing to put the particles in the air. After a year or so, they're going to fall out, and you're going to be back to whatever warming you would have had without it, and that would be what they call termination shock. Well, Leon Simons argues that we're seeing termination shock right now from the shipping regulation change.
Yeah.
And that is causing a lot of havoc. It's a very sharp rise in temperature, causing lots and lots of impacts around the world. It's not as bad as we cut it to 0 tomorrow, but that would jump our temperature by a degree, maybe, go from 1.5 to 2.5, like in a year, if we could somehow clean up all that pollution. So anyway, so that's a little bit, that's subject number one. Accelerated warming was a big story, and that led to rapid escalation of climate impacts that people are paying more attention to. Still not enough attention, as we'll get to later, but paying more attention to, and this is really hurting people in global south, and we don't pay attention to that when that happens. It's happening in the global north as well, but we have lots of resources to recover, at least for now. But that's also impacting insurance and other things like that. So insurance, by the way, I don't have it on the list, but I should have it on the list, that the insurance industry adjusting to climate change is beginning to cause havoc in places like Florida and California in the United States, probably other places around the world. Where I live, many of the homes, including mine, had their insurance canceled because we live near wildland interface. And there's still government programs to make sure you can still get insurance. Otherwise, the housing market would collapse, and they do that in Florida too. But the day of reckoning is coming on insurance because insurance companies just look at the facts, and they don't go with the politics. They go with the facts, and they know what's happening in terms of climate impacts are rapidly escalating. And they hadn't factored that in the past, and now they have to factor it in. That makes insurance very expensive, especially if you live on the coast or something like that. And so that's going to be a story for 2025, 2026 as well. So we covered that one. Again, we could spend an hour on each one of these, so I'm a little cautious about that.
So
I want to keep this a shorter show.
Is this a top 10? Did we get through one yet?
Yeah, well, 1 and 2 is accelerating warming to 1.5
Mhm.
and the rapid escalation of climate impacts, especially fires and floods. We didn't quite specifically mention fires, but
right.
We
didn't have
fires
as
have
many
gone up
this year, I don't think.
tremendously. What?
I don't think we had as many fires this year as we did last year.
Oh, in California, again, it's a cycle, right? When you El Nino and La Nina also trigger different rainfall patterns. And actually, we got all the rain in Northern California. They just had a tremendous fire in Malibu in Southern California because they didn't get the rain, right? So they had dry winds, and then they got the winds off of land, dry winds, Santa Ana winds, they call them. And that caused a big fire where Dick Van Dyke almost was killed. Did you hear about that?
No.
He's 99 years old, and he was trying to put out the fire with a fire hose or something, and his neighbors came, and because he couldn't do it anymore. He's 99 years old, and he was about to collapse. And his neighbors came and grabbed him and put out the fire and saved him. And it was his birthday, 99.
Wow.
Birthday.
Oh, my word.
So we were actually quite fortunate that the winds were consistently blowing it offshore. It did threaten Pepperdine University, and they were sheltering in place. But had the winds been even half the speed in the opposite direction, it would have been a far larger fire with far larger impacts. And there was a similar fire in November of, I believe, 1994, where again, it was maybe a little bit further north of where this one was. The winds were consistently blowing offshore, and then for a little while, just a little while, they turned around, and that really changed things. So this is, it's you're balancing on a knife edge with the outcomes of a lot of these things.
Yeah, and then again, other major things. We had this flooding in Spain. I mean, there's been a lot of climate disasters happening. They're going to keep happening. We're at a big jump in temperature. We're going to get a taste of what 1.5 is like, and that's not telling us what 2 is like. 2 will be very, very different, and will be a lot of the other thing, tipping points, which we'll talk about a little bit. So we also talked about climate science is conservative. And that's becoming more apparent as we're finding out here. And the climate scientists, when they see these jumps in temperature, don't know what to say. They could go along with what Jim says, but it's outside their comfort zone. So what else has happened? Well, obviously on the political side, there's been essentially a total failure of climate change becoming an important issue for the public. And one of the reasons is the media has totally failed in covering climate change. They're fine at covering natural disasters. And they'll mention things like climate change. They'll say, oh, this was made worse by climate change, Hurricane Helene or something like that.
But that would piss off their advertisers.
But they say it, but it's
it?
not like they're really hammering it home, and they're certainly not alerting the public to a crisis, right? That's not something that they're doing. And they don't see the politicians doing it, so they don't think, well, I guess if the president isn't saying this is a problem, then obviously, maybe we shouldn't say it either. And that's a big problem because no one is. By the way, for those who are interested in the political side, I was just listening to our recent interview with Dan Kamen, who was in the Obama administration in the climate side of things in the White House. And he's a climate scientist at UC Berkeley and things like that. Interesting discussion about, and I really questioned him on this. Why didn't Biden do anything on climate? And you'll say, oh, well, Biden's doing a lot. He did the Inflation Reduction Act and everything like that. Yeah, sure, he did that. But both of them are overseeing the largest increase in fossil fuels, like in history. And Trump didn't stop that. Trump was in between, but yeah, he did it too. But the quote, good guys on climate were also supporting the expansion of fossil fuels tremendously, including LNG, which is really bad. And this is what we're dealing with. So there isn't anyone really taking climate change seriously. And I think that if I had to give you one message, you want to think that the leaders they know this is a big problem and they're doing something about it so you can sleep well at night. Well, you can't sleep well at night because they're not doing anything. And one reason they're not doing anything is the public isn't insisting that they do. And the public isn't insisting that they do because they don't know what the hell's going on because no one is telling them. And we're saying it here, but we have a relatively small audience, and there are obviously other channels talking seriously about climate change. But it's a niche. It's still a niche when it should be something on the front of everyone's lips here.
Well, not only that, and I think this is summarized really well by an exchange that somebody in climate, I forget who at the moment, had with an NPR reporter about their coverage of the incoming Trump administration, and was critical that they weren't raising some obvious points. Oh no, excuse me. This was about health and human services, but the same applies. So the person asked the NPR reporter, why didn't you raise these issues that were obvious to the topic that you were discussing in terms of the planned policy, and just that they ignore reality. And the NPR reporter responded, "We're not the opposition."
Right.
And
Yeah.
and this is, the incoming Trump administration has really intimidated all of the major media outlets, and they seem to be quite reluctant because of the threat that their licenses are going to be gone after. And
And by the way, they will try. I mean, this is an existential threat. I mean, we have existential threats to our form of government in the United States, and around the world, by the way. It's
which
happening
climate
other
will make
places.
worse, and that will make our response to climate worse. So it's a
Well,
nice.
except I gave my silver lining possibility, no guarantee on this one, but the silver lining possibility is that with Obama and Biden, we had presidents who spoke eloquently about climate change and made you feel that they understood and were taking action on it, but they weren't at all, which is very dangerous, by the way. I mean, they did some good things, but then again, they did some bad things, which totally countered the good things. And on net, just made things worse. Uh, maybe not as worse as Trump is going to try to make it, but having someone who says they're doing something when they're not is very dangerous. Whereas Trump is going to say, I'm not doing anything. If you ask him, he'll tell you he's not going to do anything. He's going
And
to be
there's no
super
problem at
clear
all.
about that. And no one's going to doubt that Trump will do nothing for climate. And at the same time, climate impacts are going to escalate seriously over the next 4 years. And we're going to see a lot of that. And now you'll have bad impacts with someone claiming not to be doing anything. That may, in my silver lining scenario, lead to the next president actually taking serious climate action versus pretend climate action. So I don't know. It could go the other way. You could get more authoritarianism because of the climate impacts and the more migration, and they're going to blame the climate on the immigrants and stuff like that. So it could go either way, but if we're smart, maybe we'll help guide it to the right way. Let's see. Hold on. Let's see for Dr. Brian here. Okay, Dr. Brian, you should be able to unmute and make your
Yeah. Thank you, Dan, and
comment.
greetings, everyone. I appreciate that the next president might be a little more responsive than the incumbent one. However, or incoming one. However, I do want to quote a friend of mine, Sir David King, who said, "Our actions in the next 4 years will determine the fate of civilization for the next 1,000 years." I just want to emphasize the delayed and amplified feedbacks that the climate system is known to produce. And, delay is the same as failure at some level. So I encourage us to take as much private action as we are at the Climate Foundation in lieu of the government action or lack thereof.
Yeah, well, a couple of things on that. Yeah, it's true, but it's also true that our inaction of the past 40 years has locked in changes for the next 10,000 years as well. I mean, we've already done that and we're doing it more. And it's not a question of yes or no, it's a question of degree to the point where, again, I think the big thing is tipping points, which we're going to get to a little bit later. But, once you go over a tipping point, by definition, they're irreversible, right? That's the whole point of a tipping point. And then it won't matter what politically we do.
I got to mention there is an asterisk to that.
Okay.
When you're talking about things like sea ice loss, for example, there are tipping points for that. That's assuming there is no solar radiation management, right? It wouldn't be good to go over the tipping point, but the consequences of going over the tipping point where there is, robust solar radiation management applied versus not are very, very different.
That is true. I agree with you on that point. I think still it's important to recognize the hysteresis built into the Earth system, such that a stitch in time saves nine, or conversely, reversing Antarctic melting may be a lot harder in 20 years than it is today.
Absolutely.
Okay.
Well, there's also the AMOC, of course, which I don't think once it does collapse, SRM I'm sure would have some kind of impact on it reforming in hundreds and hundreds of years, but it's not going to bring it back, once it collapses. So yeah, there's certain things you can maybe do quickly with SRM. So it brings up SRM, and that's one of the big issues I think of 2024 is that SRM, solar radiation management, also known as sunlight reflection methods, also known as solar geoengineering, and then there's this particular kinds like we talked about stratospheric aerosol injection. We talked about well, there's also marine cloud brightening, there's space-based, there's a lot of different forms. But SRM will use that term for solar geoengineering. That SRM emerged in 2024 as a mainstream climate solution, one that was known before and talked about before, but very quietly. Scientists who worked on it, for the most part, with the exception of David Keith, were doing it in the evenings or with very, very, very little funding compared to, I don't know, like funding for researching new tomatoes or something was probably a lot higher than it was for SRM. And that has changed in 2024. I saw it directly in that where my alma mater, Cornell, sort of had some SRM research that they do. We interviewed two of them, Doug McMartin and Danielle Visioni. And I spoke with the dean of the engineering school about this, and they were supportive of actually supporting SRM. Now, of course, they were doing it a little bit anyway, but without talking about it, without like publicizing it, without official support. And so now that's happening. David Keith moved from Harvard to the University of Chicago, establishing a major center on climate restoration. And so it's becoming a mainstream thing. People are talking about it more and more. And why are they talking about it more and more? Because of our continued failure to act on climate. So that's another big story, I think, of 2024. And that is the realization.
A little differently why they're talking about it, because the reality is we are cooked without it.
Well, that's what I'm saying. Okay.
In the literal sense, as opposed to how the kids say it these days.
Well, no, but I mean that's my point. And one reason that realization is happening is because also I think in 2024 there is certainly not there yet, but I would say there's a growing realization that the emissions reduction only approach, as opposed to the triad of emissions reduction, carbon removal, and SRM, but the attempt to solve climate with only reducing emissions, that is becoming less tenable because for two basic reasons. One is we've already put so much CO2 in the atmosphere, 2.4 trillion tons. So the additional 40 to 50 that we put up every year is only like 1.5%, 1.8%, something like that. And so, simply put, there's already too much in the atmosphere. So stopping it when there's too much is not an answer, but that's only part of it. The other part of it is the people realizing, and I just heard Jonathan Foley give a talk yesterday, a recorded version, and it was after the election. So he was going on about, I mean, he's one of those emissions reduction only folks. Mm-hmm. And he was having a hard time putting on a hopeful case for that with Trump and everything in office. So the other answer is we're not doing it. I mean, yes, we could do it. It would be, and China's working towards it, by the way, believe it or not, even though they're the highest emitter, they're doing the most to bend the curve.
Time out. Highest emitter, but not per capita. And I think that is a vital difference because the lines on a map and who we're attributing things to and whatever it's kind of nuts because they, most of their emissions, 1/3 of their emissions is from manufacturing. And the largest importer of Chinese made goods is the United States.
I'm not sure that's true anymore, by the way. I'm not sure that actually is true anymore. Because there's a whole, a rapid shift away because they know the tariffs are coming and these kinds of things,
Well,
and they're
sorry, I mean,
they're trying to
data's-
de-Americanize their
the latest
industry.
data is 21 or 22. I mean, it's
Yeah.
not like this is an immediate thing, and sure,
It might be.
Things will shift, but
But I heard it's now
and you're
2% of
also
their GDP versus.
you're also overlooking the fact that it's all still up there. So what we did in the 1700s, 1800s, 1900s, that doesn't get wiped away just
That's right.
because, Trump's going to put a tariff on goods. You know, we're still responsible for all of that carbon that got
Right.
put
But
up
when you
there.
talk about emissions reduction only, and this is part of the problem of emissions reduction only, you're only talking about reducing current and future emissions. You sort of are wiping the slate clean on the past. And first of all, even on a country basis, the US is still twice as much as China, even today, when it comes to cumulative emissions. And as you point out, when it comes to CO2,
Yeah.
cumulative emissions is the only thing that matters because it essentially stays forever in the atmosphere.
Yeah, we are still
when you
double the
look at per
closest-
capita, so China is higher on a yearly basis today as a country, and maybe half on a per capita, roughly. It's maybe roughly half.
No, they're like 5 tons a person. We're 18.
Is it that much? Okay.
Yeah, we
So I
are
thought
the
they're going
problem.
up a lot. They're going up a
Saudi
lot.
Arabia is like the only country that beats us on a per capita
Well, I think
basis.
Australia and Canada are very, very close, if not a little more. But anyway, it doesn't really matter.
I mean,
on a per capita basis, I'm talking about.
Yeah.
So, but yes, you're right. But but now let's get back to the discussion of emissions reduction only, right? That is usually looked at on a country basis. And by the way, we're not lowering our emissions. A lot of when we say that the US has lowered its emissions a lot, a big part of that is because we have switched away from coal to natural gas. And when you do that on an accounting basis, you say that natural gas emits 1/2 as much CO2 per kilowatt hour of electricity generated compared to coal. So you say, look, I cut my emissions in half. And so you count that in your national budget and you claim that you've lowered your emissions. But the reality is when you switch from coal to natural gas, you immediately increase global temperatures for a long time before the quote lower CO2 actually has an effect. Why is that? Because natural gas is almost all methane. Methane is 120 times more powerful than CO2 when it's in the atmosphere. And fortunately, it's in the atmosphere for a lot shorter time than CO2, maybe like 12, 15 years. But while it's there, it's very powerful. So that number one, fugitive emissions or leaks in the methane system, even if it's only a few percent, which it is, it overwhelms the savings you got from the CO2. And it also doesn't have the cooling smoke that kills a lot of people, but still cools the atmosphere.
Yeah.
This coal smoke cools the atmosphere, just like the ship emissions do. And so those two things together warm the planet more when you switch from coal to natural gas. So it's all BS that natural gas is a transition fuel. It's actually a bridge to disaster or whatever, you know. So so we're covering a lot of different subjects here, but so that's what's been going on. But trying to make the point that China is actually growing renewables at an incredible rate. I do want to make this other point, which is it's not a 2024 point, it's a all the time point, but people don't get it. And that is the amount of renewable energy that we produce is irrelevant to climate change. We could have 10 times more solar and wind right now. And as long as we still had the same amount of fossil fuels, climate change would be on the same trajectory. They're irrelevant because they don't cause climate change and they don't stop climate change. Now, if we use them to replace fossil fuels, then yes, they will actually impact climate change. But fossil fuels are currently at a record high of emissions right now. And so the charts you see with the solar going up and the wind going up, it's great, but all that's going to supply power for data centers and AI and Bitcoin and everything else, the EVs, by the way, as well. And so it's not lowering fossil fuel emissions. And that's what it has to do. And it would be easy to do that by phasing out fossil fuels. The renewables would immediately take their place. But instead, we're using renewables to grow our energy supply so that we have more energy to do more stuff. And that provides social benefits and all that kind of stuff, but it doesn't solve climate change. So not quite a 2024 thing, but it's an important thing to keep in mind that a lot of people miss. Okay, so we've been jumping around, so we haven't really. Let's see.
And I want to jump one further because I
Yeah.
should have asked this earlier. Someone had made the comment or asked the question, why don't we put sulfur back into ship fuel? Lose a few people, but probably less than the climate change related drought, floods, economic damage, suicide, etc.
Yes, that's true. But if you're going to do that, much better to do it in the stratosphere. And as David Keith pointed out on our interview with him, which you can look up, he said that it's 1,000 times safer from a human health point of view to put sulfur in the stratosphere versus the troposphere, or where we live and breathe. And the reason for that are three factors. One, as I mentioned already, is you need 5% of the sulfur that we currently use to provide the same cooling. So right away, you've reduced the amount of sulfur 20x. So that's great. The second thing is when you have a coal plant, the coal particles are around where the coal plant is. And so people live there. And so they're breathing it in there. But with SRM, the sulfur is all around the world, and 2/3 of the ocean, or 70% of the ocean of the world, is oceans. So most of it will fall into the oceans, and it won't affect anyone there. And the third thing is when it comes out of the stratosphere, most of it comes out of the stratosphere as rain, and basically goes right by where you breathe and hits the ground, and you don't breathe it in because it's coming down in the rain. And very little of it is in the breathable part. So for all those reasons, you add 1, 2, and 3 together, and you have 1,000 times lower death rate from SRM in the stratosphere than you do the current way we're doing it today. So the answer is, yeah, you could do it. It's all political because it'd be cheap and easy to do it in the stratosphere, but people are very afraid of doing it. And the other reason you can't put it back into ships, because if you put it back into the ships for the purpose of cooling the Earth, then it's SRM.
Yeah.
And SRM has to be governed and has to have international agreement from everyone to do it. And so as long as you do it by accident.
Unless you are the current administration with Vice President Trump and President Elon Musk, and you just do it.
Well, yeah, that's true. Yeah. And by the way, my idea was I was going to start a new advertising company that's going to write things like drink Coca-Cola using sulfur particles in the stratosphere, and we're going to light them up. We'll do it at the right time of day so it lights up by the sun. And then of course after a while it all mixes together and then it goes around and cools the Earth.
Ooh,
but the reason we did it was to make money on advertising, so it's all okay. It doesn't matter what the secondary effects are. It's only, as long as it's commercial. So that's my idea to save the world, is to start an advertising company.
And the diamonds, that would be all sparkly.
And do it with diamonds and make it. Diamonds are forever. It might be the first, the first advertising. So, all right, we're jumping all over here. Let's keep on the sort of political side, and that is one thing that became very obvious in 2024 is the takeover of the UN COP, Conference of the Parties, climate conference by the fossil fuel industry. The last two were run by literally. I mean, if you wrote it in a novel, people would reject it as being too absurd, but. That the head of the COP in 2023 was literally the head of the oil company in the UAE. And the last one was in Azerbaijan, where a big oil producing thing where was it the head of the COP or the president? I can't remember, said that, fossil fuels is a godsend and all that kind of thing.
I think so. Is the next COP scheduled for Houston? I'm not sure.
I'm not sure.
Would that be the next stop? I mean, the next logical stop anyway.
It might be a logical stop and make the head of Exxon or something to be the head of it. But and everyone kind of notices it. You can't, but there isn't another body that can take climate action. Not that the COP ever could take climate action. It requires unanimous consent, and you'll never get that for anything that's important.
That's why I'm saying the only way around this is through it with scary and scarier.
Okay. Hold on one second. Michael, you can go ahead. What's your question or comment? Michael, you can
so sorry.
Yeah, there you go.
I think the next COP, it's going to be in Belém, Brazil, actually. Yeah.
In Brazil?
In Brazil, yes, Belém. But I think there's some controversy because Belém is actually a very forested area, and they're going to build, I think, a convention in one of the most forested areas. So I think this might be a bit of a concern because, usually you want your venue to be as green as possible. But another thing would be, I think for China, I think I did mention that maybe we cannot fully trust the data because although they have put a lot of promises and etc., but at the same time, data collection in Asia is still very, and it's early stage. So not everything has been fully disclosed yet to actually warrant that, China is less or more carbon emitting yet. I think in Asia, it's like you don't have very full, complete data set to actually verify whether, what is the full carbon emission of a country yet. But I think the good thing is that it's progressing instead of regressing in a way.
By the way, I agree that maybe the data is not super solid, but we do know, they have the biggest car market in the world, and over half of all new cars sold are EVs. They are deploying solar and wind at mind-boggling scale. I think the number last year was they deployed more wind power in 1 year in China than any other country in the world had in total, except the United States. So, so without having what is their exact emissions or something, putting that aside, the trends are they are ramping up super fast renewables, and in this case, it's to prevent the building of coal plants, which they were doing on a rapid basis, and recently announced that they're going to be cutting that back. So we'll see, of course, what the reality is, but at least they want to be the leaders. They know that clean energy is the next big thing, just like they know EVs are the next big thing. And they want to be the leaders in that, and they're going to be, because they have the entire vertical manufacturing chain of all of that stuff. And we invented all of it, but we're not taking advantage of it. And part of it's because our government's owned by the fossil fuel industry, and they don't like that. So, by the way, I was listening to that Dan Kamen interview, and he mentioned that the total investment in renewables, I think it was globally, is about $1 trillion a year. And that's 20% of just the subsidies we provide to fossil fuels. So in other words, the total amount of money spent on renewables, the capital spent on it, $1 trillion, is about 20% of just the subsidies, not the capital, but just the amount governments pay fossil fuel companies, or how much they defer the taxes and the other things they do to support the fossil fuel industry. And that's the headwinds that, by the way, since China's not a big fossil fuel industry, is a big exporter themselves, they don't care about that. They would just rather become the leaders in the renewable energy, where you're not dependent on people to supply you with fossil fuel, like Australia sending all their coal to China, right? If you have your own renewable energy, you're not dependent on other countries who could try to get influence on your country So it makes sense that
How
they're scaling that
long
up.
do we think we can keep up this charade of us being the good guys? I mean,
Well, we'll see very shortly.
yeah, I don't this is it's going to become more and more apparent, who's wearing the white hat and who's wearing the black one.
Well,
Not that that's an
it's always
Eastern way of
dependent
looking at
on who's
things,
telling
but
the story, by the way, when it comes to that.
yeah.
So even in our own history, in the United States history, we were the good guys taking over the country from the Indians. At least when I grew up, they might be covering it differently now.
Yeah.
But the Indians were savages, and we were bringing enlightenment to everywhere and stuff like that. That was the story
Smallpox
when I
and,
was a kid. All the TV shows, all the movies were all that way too.
Yep.
We're more aware now, but still only a little bit. Eric, welcome. You should be able to unmute. Yeah.
I love the agenda for this meeting. So if we could talk about what's special about 2024, like more things that happened or didn't happen in this COP. How was this COP different from all previous COPs, all research findings that came out this year? And I'd love more 2024 specific thinking from all three of you. Thanks.
Well, we did a whole show on COP, also with Dan Kamen, so you should go listen to that one. Now, I meant this really to be high-level takeaways that just help you sort of orient your thinking about climate change, as opposed to getting into the nitty-gritty details. I mean, God, we're already an hour and we've covered half of it. I thought this might be a 30-minute show. I was wrong, but so I don't want to get into the details of the COP. The COP was considered a failure. It was,
when was the last successful one?
People say that was Paris, but of course it depends how you judge that. In terms of making progress on an actual plan to do something positive, that was probably Paris. But even then, I don't think any of them are. I don't think they can be successful by definition, because they have a governance system set up that requires unanimous votes on things, and Saudi Arabia and Russia and don't want to do that. So it's very, very limited in what can be done. And just look at the results since 1992 when they've been doing these things. Emissions have only gone up. So if they could do something positive, then emissions would have at least leveled out or would have started going down. But so by that, we've done the experiment, I guess, is one way to look at it. And the COP system is not a tool for reducing emissions. You can always argue, well, they would have gone up even more. Maybe, but it also doesn't matter. If they're not going down, we're screwed. So anyway, so I don't know. So I don't want to really get into but it was, I think the important thing to note is that it was taken over by the fossil fuel industry. That's the thing to know. I mentioned about emergence of SRM as a tool. I do want to mention that people think I'm techno-optimistic about SRM. And I guess you could say that I do think it's a technology that will work, because we have demonstrations of it happening a few times a century, as I mentioned earlier. And it's an engineering challenge to put that much sulfur in the air, but not a huge one. It takes about 200 airplanes that are specially fitted to fly higher than a normal cargo plane. And their mission is pretty straightforward. And there will be side effects from doing this. And this is the things that people think it's a terrible, horrible idea, because there will be side effects. But then I think everyone who says that, you have to ask them, excuse me, what are the side effects of not doing SRM and continuing on the path we're on? So, well, we should be cutting our emissions to zero. Okay, we should. Totally agree, 100% agree. We're not. And unless you can tell me how we're going to do that really soon, that's going to continue for a while. And climate change is going to get worse and worse and worse. And we're going to have tipping points that will screw up everything far beyond what SRM will screw up.
Well, so not only that, I mean, everybody jumps right to the tail risks of SRM. Whereas nobody talks about the tail risks of climate disruption, maybe except for us, occasionally, right? The tail risks are really, really awful. And what's worse is we don't really know the probability distribution that defines that tail. The data are really, really sparse.
Well, we have some ideas now on AMOC. We talked about that. I'm going to get a little more into that.
Dan, just in what I've used in your defense is something you've said in the past is that SRM is chemotherapy. We are still smoking 4 packs a day. It would be far better for us to quit smoking and hope that the cancer goes away. But it's probably not, which is the equivalent of net zero, so if we're at net zero, everything's going to be okay. Nope, we're still going to have cancer. It's still in there. So we have to figure out some way of treating it. And as soon as we are healthy enough, diet, exercise, whatever, which is the restoring our natural world the way we have just savaged it, getting our oceans, getting our natural spaces, contracting into cities, having a smaller population, not consuming so much, all of those things. We have to do all of those things, but we need some cover. And that is what SRM is. And
although I would say
we can figure it out while we're in treatment.
Your comments, Stacy. Oh, by the way, everyone, we all have to wish Stacy a happy birthday from yesterday. So happy birthday, Stacy. I did get to say that before, but offline. But thanks for all you do here on the show.
Yep.
But your comments lead to sort of the things I have down the list. So yes, however, at some point you go to the doctor. And this actually happened to a friend of mine. She went to the doctor and they said, you have lung cancer. She did stop smoking then. But, that part, the stopping smoking wasn't going to do it anymore. And she fortunately had she lives in Canada and they have a really good treatment there. And she got immunotherapy instead of chemotherapy, which maybe it's a better comparison to SRM. Immunotherapy. It doesn't make you as sick as chemotherapy does. And so she's still alive today. But with AMOC collapse, you can say, what if we really got serious now? Okay, let's get really serious and start cutting our emissions as fast as we can imagine doing it, which would be pretty fast, by the way. We could do it in 20 years, something to get almost all our emissions cut. Would that stop an AMOC collapse? Probably not. The impacts of cutting our emissions. Remember, we've already done the 2.4 trillion tons, and we're adding like 1.8% every year to that. So if we stop adding the 1.8% in 20 years from now, is that going to really change things very much? Probably not. So there are things like SRM, which, by the way, there's absolutely no guarantee that SRM will stop an AMOC collapse. But if there is anything that could stop an AMOC collapse, it has to be something that has a climate impact that acts quickly. And both emissions reduction and carbon removal, sucking CO2 out of the atmosphere, both of them take decades to even notice the impact that you did it. Whereas SRM, you do it, a year later, boom, it's cooler, depending on how fast you do it.
And another thing we need to mention, both about 2024 and net zero, is that it's becoming increasingly clear that what has been hoped for natural carbon sinks has either been overestimated or compromised by climate and ecological disruption. And so a lot of those forecasts about, well, net zero will get things to stabilize by 2050. That rests, even if there weren't any other problems with it, that rests on assumptions that are essentially outdated.
Correct. And it gets back to the conservatism, the 95%. So like if the sea level is only going to be 3 feet, then these things might help, but 50% chance is going to be a lot more than that, and then those things don't help, right? And it's similar with the sinks. You know, the 95% chance that it's sort of only this bad, I guess, is one thing. But the 50% chance of how bad it is way worse. And we are seeing, partly because of the IMO regulation change for shipping, which jumped climate by 0.4 C in a couple of years. Now natural sinks are becoming sources of CO2, and there's a lot of stories on that in 2024. Forests or the Amazon is becoming a source of CO2 rather than a sink. So parts of the Amazon. So these are the things that are happening, and it's all happening very rapidly. By the way, I've been studying this obviously for like 20, 30 years. It's shocking to me how rapidly things are changing. I thought these were things I would see over my lifetime, and on my deathbed, oh, look, you can see an actual thing that happened from climate change, and it's recognizable. Wow, look at that. And of course, you see it every day, and it's super obvious and happening much faster than we thought.
And based on your family history, you've got another 20 years to go at least. So,
yeah,
I mean,
yeah, I want to see this 2050 thing go on there.
Yeah.
Let's see how long I can last. Okay, so boy, we're not but I did want to make. Oh, I didn't finish this. When it comes to SRM, I'm thought of as a techno optimist. But the reason I support SRM is because I'm a pessimist. It's the people who are against SRM who are the optimists. Those are the ones, without mentioning names, some people that have been on our show, who think that just by reducing emissions, which we're not doing, and we haven't been doing for 40 years, but something magical will happen very, very soon, and everyone will wake up and say, oh yeah, let's do it. Yeah, and by the way, there's good news is that renewables are cheaper now. So there is a reason, just for economic reasons, to get rid of fossil fuels that didn't exist before. So there are some things like that. But assuming that A, that we will reduce our emissions, and B, that if we reduced our emissions, it would prevent tipping points and things like that, to me is super optimistic. I'm not optimistic that A, we're going to try, and B, if we tried, that we're going to do it in a serious way. I mean, I think we could, by the way. Don't get me wrong. I think we could. But it won't be until damage is so extensive that we sort of have no choice. And at that point, you're kind of screwed, right? So anyway, the point I want to make is the reason I support SRM is because I'm a pessimist, not because I'm an optimist. I'm optimistic that the technology can work, yes. But I'm pessimistic about the human system taking the actions needed. And at a certain point, some point, you have to say, even if we started now, it would be too late. I think actually 2024 is sort of that year when, and I heard it in Jonathan Foley's voice, I invited him to be on the show, who's very optimistic. He runs Project Drawdown, and it's all about how we can reduce our emission. I think all those things are great. Absolutely. We should do all of those things. It's fantastic. But you could see in his voice that the story of hope, he was really stretching it because of the failure of the political system to do what it has to do to promote those things, and whatever. So at some point, you have to say, maybe we need a plan B. And that's what SRM is plan B. So
you'll have to tell Jonathan I'm here and say hello.
Oh, if you know him well, you're going to have to invite him because I don't know him well.
We've met. He used to live in San Francisco, and now he
he was the head of Academy of Sciences, right?
Yeah.
And so I knew him through that a little bit, but I didn't know him well because I was on the board of Chabot, which is across the bay, another science museum. And but he and I battled on Twitter a bit, so I don't think he has a...
See, we met and whatever, and we used to follow each other, and then I said enough things that didn't map with how he thinks, and then he stopped following.
So people out there, if you know Jonathan, invite him, tell him that Dan and Stacy from Climate Chat have extended an invitation to him.
Yes.
Let's see. We got, I think, Brian, I think you're still able to unmute,
Yeah.
so go ahead. What's your question or comment?
Yeah, when you said 95%, it immediately made me think about the metaphor of, you've got, would you really put your children on an airplane with a 95% chance of landing? And that's kind of what we're doing.
Well, but the reality is only a 50% chance of landing. But yes, if there was a 5% chance of crashing,
Yeah.
you wouldn't ever even consider it.
Right.
You would do everything in your power. And the example I give is you're about to board an airplane, and there's two mechanics, Mechanic Hansen and Mechanic Mann. And Mechanic Hansen says, the oil seals on the engines weren't put on right, and there's a really high chance of this thing crashing. And Mechanic Mann says, no, I think it's fine. I looked at it, I think they're fine. So you have both those pieces of information. Do you put your child on the airplane? And the answer is no, you do not. And by the way, it's not even like just you. The FAA wouldn't allow you to fly the plane, right? There are rules that if there's the slightest little thing out of place, even if it's not a direct safety thing, but indirectly could be a safety thing, the plane just doesn't fly.
Well,
And and that's applied to an airplane. We have all our children on this planet, the plane when it had a T, and we have all our children on that, and we're running this thing like it's, who cares? Like, let's just see what happens. And you never do that on an airplane. So I find it interesting that we deal with risk differently in different sectors of our lives.
Yeah, part of it is it's nobody's job to make sure the airplane gets there, and if you've got accountability, maybe things change a little bit.
Mm-hmm.
Yeah. Oh, so we need an FAA for the planet. Yeah.
So let's see. Marshall, welcome. You should. Can you? Let me see. Hold on. Let me a second. Oh no, I need to do something here. Hold on, Marshall.
Maybe we need planets. No, maybe we need pilots for the planet.
Okay, Marshall,
you
you can unmute now.
Can you hear me now?
Yes, go ahead.
Okay. Well, hello, everybody. It's been a very interesting conversation, and a lot of the points you're making are very relevant. Right now, we're involved in projects south of the equator, especially in South America, but also in Indonesia. And what we're seeing is more or less in South America, a lot of the people there are really getting up in arms. I don't know if it's not being broadcast on any news that I see, unless it's in Spanish or Portuguese, and we're addressing a lot of their concerns in different ways. But talking about you need a pilot for the planet, we actually have one. His name is Carlos, and he's out of Canada, and we're forming a joint venture in Portugal. And the crazy thing is, he fixes the planes for Air Canada, and the stories he tells us are just astounding. And some of the things that he comes across are very affected by climate when the plane is flying. So it's just amazing. The one point I wanted to bring up is the deforestation of the Amazon, because we're involved in some of those things down there. And just recently at Climate Week, if you remember Climate Week, we attended a private meeting of a group that funded a forestation program in Panama that is simply huge. And they're trying to get that off the ground more and more around the world, because they believe that reforestation can actually make a difference. Then again, who knows? Will it affect AMOC? I don't know. But I'm just saying that there's a lot of things going on, and it's not coordinated amongst anybody. There is no FAA for climate in the world, or let alone in the United States. And it's probably likely not to be in the United States coming down the pike after January 20th. So I think it's all up to us to make the difference. That's my point of view. I understand that there's a lot of pessimism, and that you're a pessimist, made your point. But I think that pessimism or not, I think we all have to make an effort if nothing else, for our children and great grandchildren. That's my point of view.
Okay, yeah, that's, I think another point I had to make here today, and it's related to the fact that the failure of the hope message. One thing we've seen is that hope message, that if we only cut our fossil fuel emissions to zero, then temperatures will stabilize, and these kind of hope messages, they don't work to mobilize public action. There was no discussion of climate change during the last election from either side. And it wasn't a voting issue. I mean, I guess if you were for climate action, you voted for Harris, but it wasn't like she mentioned climate. She said, oh, we'll continue fracking in Pennsylvania. That was her message, right? And she probably would have continued Biden's policies of supporting LNG and fossil fuel expansion. So, so this message of hope alone, it totally fails, because why should you take action on climate if everything's okay, or everything will be okay? I guess that's.
I totally agree with you, but there's things that people don't know. I'll give you an example. So
a lot of people don't know.
Yeah, a lot of them. So everybody, back in 2023, we attended the emergency roundtable of the African Union's project on the Great Green Wall to go from Djibouti all the way to Senegal to plant 1 trillion trees across the southern Sahel. A lot of people don't know about it. It's not broadcast, but it's still going on. The big issue that came up was they had 26 or 20 billion dollars in pledges, but no money. And they were arguing about it. Then we got up in the dais and we brought a solution on how to solve that problem. The reason that people were upset is because if they do put money into Africa, it disappears and it doesn't get to where it's got to go. That was the big issue. I think we've solved that problem. And we're taking efforts to get it going. We then became part of the African Union Great Green Wall project. And then we were brought to the White House, the Biden White House, not the old one before him and not the one coming up. And we discovered something remarkable. And why they don't talk about it, I don't know. But we were invited not just to see the president or the vice president. We were invited to the NSC, the National Security Council. That involves the CIA, the FBI, the military, everybody that ensures the security of the United States. What Kamala Harris did, unbeknownst to me until we got there, was they appointed 2 new directorships for the NSC. Now, they'll probably be wiped out with the new administration coming in, but they appointed, and both of them women that were really brilliant. One is currently the director of climate security for the United States. Have you heard of it? Probably not. And then there was also a director for global food security, not U.S. food security. They understood that global food security is like weather or like climate. It knows no boundaries. A war in Ukraine affects farmers in Africa, which affects farmers in Ecuador, which affects the farmers in the United States. They get it. So somebody got it, and that was Kamala Harris, and she was the one that made that initiative. Why that wasn't broadcast, I don't know.
Well, again, that's my point. My point is not that there aren't good things going on, and congratulations on what you're doing. I would tell you to keep in mind what Kevin Anderson said about trees. He said, plant trees for good tree reasons. Don't plant them for carbon reasons.
Right.
But anyway, there's a lot of good reasons to plant trees and
to
do reforestation.
Our approach is a little different than what you're stating and what he's stating, and we agree with it. But the point is that in order to plant trees, you not only plant trees for good tree reasons, but it's agroforestry today, not just forestry, because people need to eat. You need to eat. I need to eat. Our grandchildren
but you're making my point. And
yeah,
my point is, while there are
you.
things that are good and there may be parts of the government that focus on some of these issues, the public is unaware of the danger they face. And part of the reason, and this is the point I wanted to make, part of the reason they are unaware is that climate scientists are not freaking out. It's a simple way of putting it. I mean, some of them are, and they're doing it privately.
Yeah.
But they're not letting the public know how bad things are. We had Aaron Thierry here talking about how climate scientists have to become more activists. We've had a lot of people talking about these things. So that's the issue. The public is not aware of how bad things are. They see the increase in weather disasters and they go, wow, yeah, that could be related to climate change, maybe. You know, they got a little bit of that. They don't understand about the AMOC collapse that's looming and how high the probabilities of that are. And they're totally unaware. And the government's not telling them. The media is not telling them. For the most part, except for this show and a few others, climate scientists aren't telling them. And that's one reason. There's a lot of other reasons, but that's one reason why there's so little climate action. So I think but good luck with what you're doing in Africa.
So just one last statement for you, and that is continue this show, continue to get the message out that you're propagating. But remember one thing, we don't know what we don't know, which means we have to ask two questions. When people tell you it can't be done, ignore them and continue to try to your best to do it, to fix what you got to fix. And the second thing is ask yourself the most important question of any of these endeavors. And that is, what do we need to know to be successful? And I'll leave it there.
Well, I would say, and we did a whole show, did two shows, one on 20-point global action plan, which is my 20-point policy plan to address climate change. I think we know almost everything we need to know to take serious action on climate change. We'll learn more. We'll figure out more things. But we know what we need to know. We also know what's preventing us from taking climate action. And it's not just disinformation and money from the fossil fuel industry, which certainly that's part of it. And it's, as Kevin Anderson was saying, you know, that the scientists have to speak up more and not play along and make things sound okay. And all those things, but there's also psychological barriers where our brains are just not wired to deal with long-term problems. We grew up on the savannah a couple 100,000 years ago, where the only thing we had to worry about were two things: what am I going to eat today, and what's going to try to eat me today, and everything else, 2 weeks out was irrelevant. And so to take something that's a year out, 5 years out, 10, 20 years out, we're just not wired to worry about it. We want to worry about what things are happening today.
I think
Happy birthday, Stacy. Happy birthday.
Oh,
I'll leave it
thank
at
you,
that.
Marshall.
Thank you.
Dan, I think when we started this show, you were saying things like 100 years out.
No. I knew maybe 100 years was sort of the 2100 target.
Or 2100, right. So 50, 75 years away. And now it's the 20 is.
Well, the tipping points are something that we all knew about, we talked about, but they were also this amorphous future thing, 2050 plus maybe 2100. And now, and that leads us to sort of one of the final, there's a few other things, but final things I'll leave on a hopeful message, but is the AMOC. So one thing in 2024, and we've been covering it for like 3 years, but the mainstream coverage of the AMOC, the Atlantic Meridional Overturning Circulation, the ocean conveyor belt that brings heat from the tropics to northern Europe, and it's driven by heat and salinity, is slowing down and could be reaching a point where it shuts down. We've done a lot of programs on it. Go look at past programs to get the details on it. But one thing that's happened this year is that the research so the IPCC, previous in the last report, said the chance of this shutting down this century is very small. But all of the research, but a lot of the research in the last year, including from Jim Hansen, from Peter Divlitson, Renee Van Weston, and even last week with Gabriel Pontes, all is pointing to this being a much more serious problem with a shutdown, which, by the way, might have already started, and we won't even know about it for a while. But certainly in the next 20 years is sort of the main time when it might happen. And once it happens, it is irreversible for any reasonable time frame, hundreds of years at least, and maybe thousands. And it screws up everything. So I think one thing that I think we'll see emerging in 2025 is a focus on AMOC as a danger point for climate, which is in my mind, a better danger point than 2C. Because 2C, first of all, doesn't, so 2C, what?
Yeah.
It's warmer. Okay, what does that mean? Actually, it means a lot of things that are terrible, but but no one knows what they are. And they're probably going to happen at 1.9 C, and they're probably going to happen at 2.1 C. So it's amorphous. The target's amorphous. You can miss it by a little bit, but AMOC collapse, you can't miss it by a little bit. If it happens, it happens. There's a point where it weakens, and then it becomes self-fulfilling, and it weakens itself, and that's when it collapses.
I will say that what was clear before this year, and this is having to look deeper into how people arrive at their conclusions, was that from the risk perspective that you were talking about earlier, that there was no basis at all for the confidence that we have high probabilities of avoiding all of the amplifying feedbacks that could turn out to be very catastrophic. The data that goes into assessing them in many cases was really sparse, and they made assumptions about the deviations from model outcomes being normally distributed, which is just it's just pulling something out of the air essentially for convenience. It's the spherical cow of climate modeling.
People don't know that reference, but anyway, it's okay.
Well, a simplifying assumption that makes the math tractable, so to speak, which departs from reality, right? And so from that perspective, it's been clear to me for many years that anybody who's confident that we don't have to worry about this climate amplifying feedback or that climate amplifying feedback, they are on very thin ice in terms of a well-supported argument.
Well, by the way, one of the comments in the chat is AMOC makes a good talking point. It's from Tom S. AMOC makes a good talking point, Dan, but it sets us up to be Cassandras. Well, I think 2C sets us up to be, they all set us up to be Cassandras. But I think, again, you don't want to actually ever reach the danger point. You want to not reach the danger point. That's why you bring it up, right? If let's say we now know there's absolutely nothing we can do about AMOC, which may be true, by the way, but we don't know that. We do think there are some things we can do to prevent it. Then you want to prevent it and not have it happen. So you're not really a Cassandra at that point. I mean, yes, people will say, see, it didn't happen anyway, but it's because of the actions you took. I do think that one thing we will see in 2025 is a continuation of what we saw in 2024, where the data will keep coming in that the AMOC is weakening at a fairly rapid pace, just like last week's program, a very important program with Gabriel, explaining how it's gone down like 15% already in like 70 years, and in the next 20 years, going to go down another 15%. There's some point where it becomes self-fulfilling. It might be at a 30%, but somewhere between a 30 and a 50% slowdown of the AMOC, which will be at certainly like 2050, it just collapses on its own. And we can get into why that is, but that's a detail. You can go listen to the other programs.
We really hope to never have certainty about that answer.
Yeah, that's a good way to put it. Let's see. We have, Stacey, go ahead.
Yeah, I was just going to say we have Eric and Brian, and I have a few that I have harvested from YouTube.
Okay, and I'll save my one little sort of positive note for the end. Not too many positive notes here. Eric, go ahead.
Okay, so I'm a little bit confused about this point. Let's assume, does Brian or any of you co-hosts think that if the scientists were to suddenly start saying the perfect words, that greenhouse gas emissions would go down dramatically? I mean, we're talking as if, okay, I'm not saying the perfect words, but I'm missing.
No, I'm not saying that. What I'm saying is that scientists, and then again, Kevin Anderson was saying a version of this too, that the current messages of hope and, hey, we got this, we can do that, even though, it's been bad. It's been bad. Oh, it's been bad. But we can now do this. Those words are not helpful because the public hears them and says, oh, I heard that if we get down to net zero, and everyone's talking about net zero, we get down to net zero, temperature stabilize and everything will be fine. Well, there's so much wrong about that, which we could go into. But so I'm saying a different message. Oh shit, AMOC is on the verge of collapsing. Let me tell you what happens when that happens. And it's really bad, by the way. It's kind of mind-boggling, right? It is a catastrophic event if that happens. It's not that every place gets worse, but every place gets different. The monsoons shift down south. So everyone's worrying about the monsoons and SRM. The SRMs might impact the monsoons. Well, the monsoons are gone. I mean, well, they're not gone. They move away from the 2 billion people that they support if the AMOC collapses. Northern Europe becomes uninhabitable. There's a foot less of rain globally across the northern hemisphere. Everything's different, and it just fucks up everything, right? That message is hopefully a scary message, like Russia's about to invade Oregon tomorrow, that kind of message. And it just might, if the public was worried about it, which they're certainly not today, so let's not pretend they are. But if they were worried about it, then elected leaders and military planners and things like that would have to take steps to study it. And by the way, I've had interactions with the government on this subject, and without getting into too much detail, there's not much going on. So if you think, oh, this is a really important issue, the government's taking care of it, you would be wrong, okay? And so the point is, let's find a message again, with the hopeful message about what we can do to address the problem. But let's not confuse the hopeful message and make it sound like it's all okay. It's not okay. This is really scary. It'd be really bad if it happens. And oh, look, if and only if we take the following actions, which are like 3 things: reduce our emissions, take CO2 out of the air, do SRM to immediately cool the earth while we do the other things, then we can address that problem. But the current method of, hey, it's not good, but you know what? We're working on it. That's a terrible message. Okay, Eric. Yeah. And we'll move to Brian. Brian.
Yeah, in a nutshell, the Pollyanna predictions on emissions only are not only dangerous, but they're irresponsible and to some extent suicidal. And we have to really, I think, get that message out. But I'm reminded of Einstein's statement that we can't use, 2015, we had a consensus on 1.5 to 2 degrees. Who would have predicted in 2015 that we'd have annual temperatures above 1.5 Celsius in less than 10 years? And yet we do.
And we'll be at 2 degrees maybe in the 2030s. Probably at least one time, maybe not a trend, but yeah.
Right. So, it's just, that's a case where people are still arguing about whether we're at 1.5. And so, that what's really concerning is how is AMOC going to show up any differently? In other words, there's going to be a bunch of prevarication, and then people are going to argue whether AMOC has shut down or not, and then it's going to be too late. So
well, once it shuts down, it shuts down, right? So yeah, it's not. It's more about, is it a better target, a better point to focus on than 2C? Because again, you can go over 2C and hit 2.1. And everyone will think that's fine. By the way, the problem with 2C too is that it itself is catastrophic. And if we do assume that if we cut our emissions to 0, that temperatures stabilizing at 2C is not a good thing. It's catastrophic because it leads to other tipping points, and it itself has crazy, horrible weather extremes and all these other impacts. So it itself, I consider a tipping point. 2C without SRM is a tipping point in that you never get below 2C again, right?
I have to agree with you. And I think the problem is less about which planetary boundary we're exceeding and more about the governance methods that aren't working for actually addressing any of those planetary boundaries.
Yeah. So my 30-minute talk is turned into a 2-hour talk here. But go ahead.
I still have questions.
Let's stay. Brian, are you?
Yeah, I'm done.
Yeah, Stacey, go ahead.
Okay, so This one, I thought I didn't know how to answer it, and I am curious because this is something that I've seen an uptick here in San Francisco. Do you think lightning will play a far more significant role in the future?
Lightning. Well, there was a lot of lightning in Spain, and when they had the incredible rains.
Mm-hmm.
Lightning is one of the natural causes of forest fires, and of course, man-made ignition sources are the other cause of. And people think, oh, well, since it's man-made, then therefore that's what's contributing to the increase, and that's not true. So there always were man-made sources, and there always was lightning. What's happening now is that the forests are drier and more susceptible to burning large amounts when there is an ignition source. So in that sense, they'll play a bigger role, and that when it does happen, they can trigger larger forest fires. I don't know the details on what it's going to do otherwise. But I think there certainly might be more. There was a tornado warning in San Francisco recently,
First
the first
ever.
time, first
Yep.
ever.
Yeah.
And anytime,
First
by the way,
ever in
anytime you
LA
hear first
earlier
ever,
this year.
that's climate change.
Yeah.
Period. First ever weather related is climate change.
The next is, what indicators will you be looking out for? The obvious CO2, CH4, N2O, SST, EEIs, any less obvious ones?
Well, I think the thing that we're looking at now, and again, a lot of guests on our show like Leon Simons and Jim Hansen, is we're looking at the Earth energy imbalance. We're looking at incoming solar radiation. We're looking at emitted energy from the Earth, and those things separately, because that's what you can tell whether it's aerosols doing it or whether the sun is stronger or more greenhouse. You can tell what is greenhouse gas related versus reflections of particles and things like that. So I think there's going to be more focus on that. I think there's going to be a lot of focus on the AMOC, trying to measure it in different ways, trying to see what the trend is recently. I think the other thing we're going to do is look at politically whether there is any social movements that grow. Remember, what's happening as the social movements like Just Stop Oil, Extinction Rebellion, as they grow, governments make climate protest illegal. There's all these stories in England. There's a woman, a 90-year-old woman or something, who had small wrists, so she couldn't have a tracking tag on her wrist, and she couldn't put it on her ankle for some reason. So now they threw her in jail for Christmas. That kind of stuff. But they're just making these huge long sentences for people who were peacefully protesting, versus people murdering people and stuff like that. And hold on one second. Sorry,
So
that.
I did want to kind of go back to Eric's question and tie that back to a few other things. We're seeing a total failure in leadership. Eric asked, what could climate scientists say that would shift things? There isn't anything, because leadership is not interested in leading on this in any way that we would expect of truly conscientious leadership. We are also facing challenges on communication of information to the public, so democratic action is going to be impaired. What we have to do, this is my personal view, the problem is a failure of the kind of civilizational infrastructure that we have. We need innovation in the way we meet our needs as a species and the way we interact with our natural environment. And we need to create technologies and industries that operate in such a way that the easiest thing to do, the most economical thing to do, the best thing for the climate that could be done is simply the way the system operates. And this is not on anybody's radar, really. We have to create it. This is what will change the menu options that, quote, leaders have to even consider. When energy that doesn't contribute to climate disruption, but perhaps is involved in being a carbon sink, is the cheapest form of energy, that will be a radical change, right? And you can change the topic in similar ways, but basically, we're now in the herding kittens category, and we need to adopt a totally different paradigm if we're going to. My view is the most pragmatic approach to this is to totally change strategy to something that will encourage all of the players to decide that there is something better.
Okay. Well, and also if you listen to our recent interview with Kevin Anderson, he's saying that, it's not possible to stay safe by just reducing emissions. You actually have to reduce demand. You have to actually use less energy, and that's very doable, especially since the top 1% use more energy than the bottom 50% times 2, and the top 10% use 50% of all energy. And emission, by the way, there's more emissions than energy. So if he's right, there's social changes that, again, this is where I'm very pessimistic. I'm not disagreeing with him that that's something that we have to do, but there's a really big difference between what we must do and what we will do. When you say must, well, if it's must, then we're going to do it. No, must means you do it or you suffer unacceptable consequences. And we are choosing, and it's a choice, we are choosing to accept unacceptable consequences. If we really understood what that meant, if we could see the future, if it was like the ghost of Christmas past and present and future, if we could see the ghost of Christmas future and see what it's going to be like, then maybe we would act differently, but we don't. Again, the message from the media, the message from politicians, the message from climate scientists are that, yeah, very serious, very, very serious, really serious situation here. But if we get to net zero, everything will be fine. So we can continue doing what we're doing for now, and we'll have these, great technologies in the future to keep us safe. And the problem is, of course, things can all fall apart. Once a tipping point passes like AMOC, it's not game over, but it's a whole new game. I'll tell you that. It's a new survival game out there for food and shelter and war.
It's hard mode.
It's hard mode. So, all right. So
I have just a little more. Okay. The one is a very interesting fun fact. Albert Bates says, true story, Arrhenius is Greta Thunberg's great-grandfather.
That's correct. Yeah, I've mentioned that.
Wild.
And her father's name's Svante.
Come on, I'm here every week. How have I not heard this? Okay.
Yep.
And then the last two questions. One is OpenAI just released O3 model, which is AGI. Well, actually, I just saw something that said it's not AGI, but this person said it's AGI, smartest human on earth. 2 to 5 years, it will be super intelligent. Probably it can solve climate change by then. Pragmatically, it is our main hope. Thoughts? And my response was, it will understand that we're the virus and get rid of us.
I don't know. My experience on this show, on this particular show, of getting the graphic designed for this title slide was that OpenAI ChatGPT is the stupidest thing on earth. I told it, okay, you got the Earth with a thermometer. That looks good. And got the sun. The sun is in the night sky. Maybe put that get rid of the moon and get rid of all the celestial bodies. And it just said, okay, I got rid of the moon and all the celestial bodies. And all it did was add more moons and celestial bodies and stars and everything. I said, no, get rid of all of them except the Earth and sun. And it said, okay, I did that. And it added more. It was like stupider than a 3-year-old. Like if you were explaining, don't draw that anymore. And I was like, wow, this is like, so it's really good at certain things, but it really doesn't know what the hell's going on, right? It doesn't have context. I mean, on certain things, it's really good, though. I mean, you can look at my poem it wrote on climate change in the voice of Shakespeare, and that was pretty mind-boggling. So, but at times it's really stupid. I don't know. We covered AI as an energy source a few programs ago, and that's really dangerous. That we're ramping up energy use, and even if we used renewables for that, it will take away from the fossil fuels we could have displaced.
Yep.
And you can't solve it by making it more efficient because it just makes it cheaper, and then we'll just use more energy in total. So that's not a good one. But let's keep going.
I would say that, we actually know plenty of the things that we need to do. The one thing that AGI could contribute is kind of giving them the super intelligent seal of approval.
Yep, there's that whole thing. But we haven't really covered. We tried a little bit. Remember, we did with Will Wright. We did what's going to kill you first, climate change or AI,
Yeah.
and he conceded
Right.
it's going to be climate change.
And then the last one I have is, what are your own views of what 2025 will bring climate-wise? Any of the tipping points crossed?
Well, we won't know. By the way, we may have already crossed, right? The thing about a tipping point is you don't know whether you crossed it until after you've crossed it. Usually, you look back, and someone pointed out maybe we started, like if you asked when Germany invaded Poland whether World War II started then, but back then no one would have said World War. It was only looking back that was the triggering point. And so maybe we passed the triggering point for, well, by the way, it could be AMOC collapse, or certainly it seems like we've already passed the triggering point for West Antarctic ice sheet collapse. That was 10 years in the past. And so there are certain things we're committed to, like lots of sea level rise and things like that. But so I think we're going to learn more about the dangers of tipping points, like we did in the last couple of years. We'll learn even more, especially on AMOC, because now there's a lot of attention on it, a lot of papers coming out on it. The last week was a really good one. If you want to learn about AMOC, go listen to that. And that kind of thing is going to ramp up. Yeah. So we'll always learn more about the dangers, and we'll also learn more about the solutions. But it's not the science, it's not the solutions that are the problems. The problem is the human system. It's human cognition. It's our political system. It's run by fossil fuel interests that don't care about what's happening. And so unless that changes, we're pretty much on a path that's not going to work out very well for everyone. So, but okay, keep going. Unless there's others, I want to end on the sort of
No, I guess
semi-happy note.
My only thing is, my daughter and I are Luigi stans now, and I just keep wondering, when's it going to be an oil CEO? Because
I was surprised that it hasn't been. By the way, that's in the book, Ministry of the Future, that is a rampant thing at that point. And so,
and that's one where I don't think it should just be one to send a message. I think it should be an orchestrated effort.
I wouldn't
all
agree
at
with
once.
that. I wouldn't say that publicly.
I got nothing to lose, Dan.
Okay.
They're gonna come after the mom. Okay, come at me.
Hey,
yeah,
they're doing it. They're doing it in the UK. Don't get it wrong. They're doing it. Guys, you can remember it's the fossil fuel industry that's fueling the changes in the law to make climate protest illegal. Right?
This is
and they do have a rather ruthless track record, at least.
Yeah. I mean, everywhere else in the world, right? So check it out. So watch out. But kind of speaking of that a little bit, and a little bit on the quote happy note. One thing that is happening,
that's quite a spin,
is that renewable energy is getting incredibly cheap. Battery prices are dropping crazily. They've dropped 90% in the last 10 years, and they're continuing to drop dramatically. There's a little oversupply right now that's helping the prices come down, but they're at sort of the $50. It used to be $1,000, like in 2011, 12. It was like $1,000 per kilowatt hour for a lithium ion battery. Now it's like $50 at the cell level, maybe $80 at the pack level in China, which again, where they're doing most of the EVs. But it's also great for energy storage. And there's new technologies like sodium batteries, salt batteries, basically. Don't use lithium and the lithium iron phosphate, which are much safer, and don't use cobalt and these other rare things that, they have child labor in the Congo getting, things like that. So they're getting safer, they're getting cheaper, they're getting better environmentally, even though nothing is good nothing we do is good environmentally. So you have to compare it to fossil fuels, which are horrible environmentally on many scales. And again, for every 1 ton of lithium we extract 50,000 tons of oil and 100,000 tons of coal. You have to put it in perspective there too. But I'm not saying that, lithium mines don't have negative impacts. They do. But that's getting cheaper, and therefore it's enabling, from purely an economic point of view, a transition away from fossil fuels. Now, the fossil fuel companies, since they are subsidized, remember $1 trillion going into renewables, 5 trillion going into just the subsidies for fossil fuels. If you were able to just eliminate the subsidies and did nothing else, then it would be like a no-brainer, and the economics would just push fossil fuels away. And then if you add the fact that fossil fuels should pay for the climate damage they do, so you have a carbon fee, for example, well, then it would be over. I mean, the fossil fuels would be over. So the good news is that the technology and the economics are now in place for a replacement of fossil fuels. It's not replacing fossil fuels. All it's doing is adding to new energy supply right now, because we haven't allowed those economics to really play out, because again, we subsidize fossil fuels, and 2, we don't make them pay for the damage that they cause by health, killing 8 million people a year. You would think that would be a thing that people would talk about, not mentioned at all ever. And it's 1 out of 5 deaths in the world caused by that, not mentioned ever. And also climate damage, which we're talking about all on the show all the time, not factored in. So the good news is that the technology and the cost structure is there for a rapid transition away from fossil fuels. So the point is, once we get the political power to cause that change, it can happen very quickly, and will save trillions of dollars, by the way. This is not an expensive thing to do. It will save incredible amounts of money. Eli?
I would like to add to that, when you compare the impacts of the renewables you described to the impacts of fossil fuel, they are so much smaller that, we had the show on ecological tipping points. And, I raised some examples there about how beautifully ecosystems can come back if they're just given half a chance. And that is that half a chance for many ecosystems, if we can eliminate the fossil fuel impacts, and at the cost of the renewable impacts, which are so much smaller, that can be just a beautiful thing for nature.
Right. And so a lot of people complain, and again, these are climate people that complain about, well, I'm not sure I call them climate people, but people that call themselves environmentalists complain about renewables and saying how horrible their impact is. However, if you look at total extraction, like in order to supply all energy by renewables, we would have to increase the extraction we do of the steel and the copper and the lithium and all that stuff by about a factor of 4. You say, well, that sounds like a lot. Well, that would eliminate, obviously, fossil fuel extraction. And if we did that, if we replaced fossil fuels with 4 times more extraction for renewables, that will decrease total extraction by over 99%. I'll have to say that again because it sounds weird. If we switch to 100% renewables by increasing the extraction of the minerals needed to produce those things, that's sand for solar panels, but I mean lithium, copper, all that kind of stuff, steel, it would reduce total extraction by 99% because fossil fuel extraction is over 500 times more than the increased extraction needed for renewables, which is mind-boggling. 60%, I think, of all the ships are carrying fossil fuels. So all of a sudden you could eliminate 60% of shipping and not lose anything because.
Let me tell you about those train cars as well.
And the train cars, of course.
Yeah, let's get people on them instead.
It's such a weird, incredible system. If you say, well, we can't build carbon dioxide removal, think of the scale. Well, we already did it. We did the reverse system. We built the fossil fuel pumping into. If you told me that, oh, we can build a system that pumps 40 billion tons of CO2 into the air every year, that's a really hard thing to do. And yet we did it. We figured out how to do it, right? And we're continuing to do it. So it's something that can be done. Now, if we choose to and we put the right incentives in place, it's a lot easier to scale renewable energy than it is to scale fossil fuel energy, because once you build fossil fuel renewable energy, it produces energy for 20 or 30 years. Whereas you extract fossil fuels, you burn it one time, it's gone, and now you got to do it again the next day. So the scale is 500 times more extraction needed for fossil fuels than for renewables. So the good news is the technology is there. It's getting cheaper, but even at current prices, the economics are there to replace fossil fuels, save trillions of dollars from a society point of view, reduce deaths by 8 million a year, health improvement, avoid not all climate, but avoid the worst climate things that will happen if we continue to do it. Give us a chance to kick in the other things like CDR and SRM to stabilize the climate at a safe level. And we can do it. And we could do it tomorrow, of course, if we wanted to. Now, I'm not saying we're going to do it tomorrow, but the pieces are in place there. It's our own brains, our own politics, our own corrupt systems and wrong incentive systems that are preventing us from doing it. If the public decides they don't like what's happening and they become aware of the dangers they are facing, by the way, personally, it's always the grandchildren. No. Personally, them. Hey, I already lost a vacation home, like a timeshare vacation home, and my house insurance to climate change. As someone who's been talking about climate change for decades, and many, many other people impacted far worse than I have. They might not be aware that it's climate, but that's happening more and more and more and more, certainly in the global south, but in the developed countries as well. And if they decide there's enough of that, they get scared about the AMOC collapsing and realize what that's going to mean. If we can change the narrative and get one of danger, and this is the part that I know a lot of climate scientists and politicians and others really don't want to go there. They really think it's bad. But you also have to look that the Conservative Party in the United States, they use fear as a message all the time. In the last election, it was fear of immigrants. It was fear of inflated prices. It was fear of everything. You lose your guns or whatever. It's always fear of loss. Always. And it works. It's not true, by the way. They make it up, but it still works. So we have something that's real. And everyone is afraid to be direct and honest about it. And when you're direct and honest about it, it's pretty scary. Now, the good news is there's a lot we can do. The bad news is we're not doing those things. And you shouldn't think that the government is doing it for you, the bystander effect. So I think that's what I'm going to kind of end on, is that it shouldn't feel good that someone's taking care of this. They're not. And it's only when all of us rise up and do something about it. I think if we're honest about what's happening, that message is powerful and can change things. It's still a corrupt system and whatever, but we still can change it. And we're going to learn more. And on climate change, next climate chat, we're going to be discussing all these issues going forward. Just to reiterate, if you joined later, upcoming guests in the new year include Jim Hansen with new research, which would be very exciting, Bill McKibben, David Keith, and a bunch of others that we have lined up. So keep listening, and please do subscribe. It does help. Bigger the channel is, the easier it is to get important guests, and the wider the reach of the message. As we're talking about today, it is the reach of this kind of message that is critical. It's not out there now very much. And also follow us on Twitter and especially in Bluesky. So if you're out there listening to this, please follow me on Bluesky. Its link is in the description. And there we go. So Stacey, any final words?
No, just I'm looking forward to all the great guests that we'll have. I was nervous about the switch that we did a little over a year ago from the burning down of Clubhouse to this, but it's been great.
Well, we have like 100 times the followers that we did on Clubhouse.
Yeah,
depending on how you look at it, but yeah.
So and here's to hope.
Okay. And Brian.
I just want to say thank you, Dan. You're curating probably one of the most important conversations in the world, and getting this message out. Just a big thank you to you and all the co-hosts and the whole team.
No, thank you. At times I do feel very strange that I feel like, wait a second, we're covering this subject very directly with some really important people like AMOC or this, and except for a few other places, you don't even hear about this, and it's a very strange feeling. Are we missing something? Is it really okay?
You're reminding me of Winston Churchill when he said, "You can count on the Americans to do the right thing after they've tried everything else."
Yeah, well, we're
I don't even know if
the next
going to happen.
4 years are going to be an example of what not to do. We're about to see that too. The good news on that, by the way, as I've told people, is that even though I think it's going to be a show, some kind of show, the next 4 years in our government, being aware of climate as a disaster kind of makes that disaster a little more palatable in just on a relative basis. So I'm not sure that's really a good thing, but whatever. Maybe on that, it's a good thing to
picking poisons.
So I do thank everyone in the audience. Thanks everyone for following the channel. Again, please subscribe, like, follow, all those things. Share the channel with your friends. It is important to get this message out. There is a tipping point for messaging like this when enough people become aware of not only the problems, but the solutions. That's when real action could happen. We're doing our part. Many, many other people are doing their part. If you have suggestions for guests, please let us know. The email is the old email, but it's climatechatclub@gmail.com, climatechatclub@gmail.com. And especially if you have a suggestion for a guest, please provide their contact information if you know them, kind of thing. And thanks for everyone, and we'll see you next week. And I hope you enjoy your Christmas holiday if you're celebrating that, or Hanukkah, or whatever else, and enjoy your time. And maybe don't think about what we just talked about too much during the Christmas holiday.
Happy holidays, and hope itself is a renewable resource. Let's hope for the new year.